Today we're taking a look at this Gochifix LG304 oscilloscope, multimeter, and waveform generator, kindly sent over by banggood.com. No money has exchanged hands, but they did send this for free. And we're going to take a look at this thing. So let's start by seeing what's in the box. So Gochifix seems to be a relatively new company. They make laser levels and stuff like that at the moment. So you get a set of test leads. Oh, not very supple. Kind of, a little bit cheapy. I don't know how to feel about this quite yet because this device is, I think it's going to retail for $220 US dollars, but it's not out yet. So we'll have to see if it's good. This is a USB Type-C cable. We've got a lead here, BNC to double banana. This is likely more for the function gen, because typically you want a sort of like a probe like this for the oscilloscope. And then there is a probe. Let's see what that's like. Okay, so the probe is a little bit more flexible. It seems a little bit higher quality than the test leads. Then you got your screwdriver to adjust probe compensation. You got a couple of rings to determine the channel. So like first channel will be yellow, for example. This one's yellow already, but you can change for the second channel. Except they didn't include a second lead. Like, I guess you can use this as a scope lead, but I would expect two regular scope leads and then one lead for the function gen. The problem with the alligator clip lead is it's not quite as robust as the oscilloscope lead. Then you get a simple operation guide, so a quick start guide, so that is going to be useful. And then, you got a user's manual as well. This whole thing is in English. That's good. So this whole thickness is just for this product. It's not just like 5 languages. You got a nice little case. Got a little frayed. It's interesting. Ziploc inside the case. And here is the unit itself. Seems like, apologies to all the peel aficionados, doesn't look like we're going to get a peel today. What do we have on the side here? Kind of hard to open. Okay, USB-C, but also it looks like there's space in there for more stuff maybe in the future models. It's got a tilting bail like that and a Phillips here. Now I don't know if this is rechargeable or if it's just batteries included, because the USB-C could be for charging just like it could be for data transfer or PC control. So let's see what we have in here. Oh geez. That is weird. Okay, so first of all, awesome that they use 18650s. I am all for it. Seem to be using FL 18650, 2000 milliamp hours, 3.7 volts. That was interesting that it was glued to the backing there, but I am all for 18650s. This is probably my favorite way to do batteries, because if these ever go bad, you can just order any brand that you like, or you can even salvage some, and then you've got replaceable batteries. I love it. So negative over here, positive over here, like so. Pop that in. Put the cover back in. It's weird that it's stuck down, but it is what it is. The battery pack only can be opened by professionals and don't use damaged parts. Okay. Batteries may explode. Well, let's try not to do that. Alright, let's turn it on. So that's a very squishy on button there. Is it on? Oh, it was a press and hold deal. Okay, innovation never stop. And there we go. How do you guys see that on the screen? It looks pretty good, actually. So this is one of those, mushy button type things. Not too sure how I feel about that, but let's press through a couple of things. So let's say I want to check volts. So it's already in volts. If I press again, does it do anything? No? Oh, I see. It's in volts now. You got DC volts, AC volts, hertz, and duty. So AC volts, hertz, and duty. Interesting. Let me poke around on this, and then I'll bring you back, and we'll see what the interface looks like. So it didn't take a lot of messing about with the interface in order to get familiar with it, which is really nice. I guess the first thing you kind of need to realize is that the main functions are here, and then sub-functions are these F keys. So let's say if you're in volts, so you want volts, you click this one. It doesn't make a noise, actually. I'll show you how to turn that off. Then you've got DC volts, AC volts, hertz, and duty. So you can just click through like this. Now, to turn off the annoying beeping, I hate when my devices beep whenever I touch something. You can just go utility and then beep, enter, and I turned it off. However, I am regretting this a little bit because these buttons are so squishy. I didn't realize how important the beeping was in order to know that you've pressed it. Not a fan of the buttons, I will tell you that. But again, if it performs, it performs. So here we go. I just decided that I am comfortable enough with the interface that we can go through the Kaiweets Multimeter gauntlet. So we'll check the accuracy of this, and at the same time you'll get to see how it works. So let me just hook into our voltage standard here, and we're going to flip to DCV. This is being powered at the moment by a linear power supply, super clean lab grade one. So yeah, the voltage here should be about accurate. So here we go, 2.495. Now you only get, it's only looks like 3.5 digit multimeter. So I mean, take it for what it will. If you want to do very low voltages, or very precise voltages, it's probably not your jam. It is only $220 as well. So I'm going to pull these out because they're going to be a little bit easier to do. And just going to switch over to our 5-volt reference. And take a measurement. 4.993, 994, 993, okay. 7.48, so it is a little off, I have to say. But we don't see those extra digits, so we don't know where it's coming from, the inaccuracy. 9.98 volts, okay. So pretty decent. Now let's say if I want to go into resistance, so you got 10 ohms, 100 ohms, 1K, 10K, 100K, and the 10 ohm is 0.1% accurate, the 100 and all the rest of them are 0.01%. So we're just going to hit here into resistance. It clicks over a relay in there, and then we can go take our measurements. And so we've got 10.1, oh, right within spec. And then 100 ohms, 0.01, so this is out of spec. I have tested these resistors, they are quite accurate. 1K on the nose, 10K, pretty much on the nose, and 100K. 99.9K. Okay, still pretty nice, and it even tells you which holes to use, which is pretty nice, which ports to use. Now, I want to check a capacitor. So this will be an 82 nanofarad 1% and a 100 nanofarad 1%. So you just hit the capacitor here. I was afraid the UI was going to be hard to use, but it seems to not be. So that's 82 is reading 75. That's a little low. And 100 is reading 91, 92. Again, a little low. Not too bad overall. So that's pretty good. Now, you've got current over here. Now look, they tell you where to put your leads. We're in milliamps. DC, there's AC milliamps and DC amps and AC amps. So let's go into milliamps, but I will tell you there is a little bit of an accuracy drop in current mode because of the burn-in voltage of this multimeter. Dave Jones made a fantastic video about burn-in voltage, so if you want to see it, go check out his channel. But here, I'll plug into here. Actually, that's fairly close. So we're at 10 volts going through 1K ohm. So that should be 10 milliamps. And we are at 9.97. And then we'll go even lower. So yeah, this is not even, it can't read below, I guess it can't read fractional milliamps. So that isn't working. And that isn't working really. For some reason the 10K is reading lower than the 100K. But yeah, not the thing to use for sub milliamp current readings, but it can read down to single digit milliamps, which is actually pretty nice still. So time to mess with the function generator and the oscilloscope function on this thing. But before that, I saw that there wasn't really a place to grab a test signal to do the probe compensation. And then I realized if you go AWG, this is the function generator, you could probably just set out a function, a waveform, and then do the probe compensation. So that's what I've done. So in here, the function gen, you can hit your type. You got the square, ramp, sine, and back to square. So not an arbitrary waveform generator per se. You can do your frequency. I do not like this at all. You have to type because you only have this sort of keypad and it's super squishy, right? So let's say we go 1 and then you scroll down and then around meg. And so now you got 1 megahertz. Then here you've got your peak-to-peak voltage. So I don't know, let's go 2. And again, with this super squishy keypad, no tactile feel whatsoever. Then you got your duty cycle. Doesn't look like you have an offset capable, but then you just go into the scope, channel 1. And so channel 1 is over here. And there you have your waveform. Like most oscilloscopes, I tell beginners to start with the auto key if you'd like. So hit auto. And so it's automatically, put the waveform where it needs to go. But to change your time base, all you do is you press the sideways this way to increase or decrease the time base, and this to increase the time base. But as you can see, the corners are quite rounded. You need to do the probe compensation. Also, on the screen here, you'll see 1 megahertz up there. To get that, you go menu, and then you scroll down to time, and then anything you click on here, you see frequency has a little dot in front of it. Well, that'll appear there. It's a little bit like just display functions, but it takes up part of the screen because the screen is quite small, right? So we can go back by hitting menu. And let's see if we can do our probe compensation now. So your probe compensation is just sort of adjusting the capacitance of the probe, as far as I understand. So you want to match it to your source. So I'll just turn the little screw in there until the corners are sharp. So that is doing all of nothing. And for some reason it's affecting the amplitude. Alright, let's try going down to 1 kilohertz. And back to your scope. And we're going to auto trigger. Okay, so that looks a little bit better. But obviously probe comp needs to happen. Turn this. So maybe I was going a little too fast. There we go. Nice solid square wave. And you can see it very clearly there. So that's actually pretty neat. I don't mind that at all. My only thing now is that if we turn on channel 2, what are we going to do with it? There's no way to hook on another probe because they didn't give us another. That's a little bit of a disappointment. And typically the sampling rate will have to be shared between both channels, so that typically affects the way the performance is on this thing. However, can't really test it without another probe, so I'll have to borrow a probe from something else. But it's nice to see the function gen in here is functional. Let's go ramp and back to channel 1. It does go very quickly. You can turn off channel 2 as well. Oh, there we go. Channel 2 is off. You can even change our triggering points. So rising edge, falling edge, on the channel, the triggering mode, and the reset the level at which it triggers. Go back to the function gen and try something else. Sine wave. Back to the scope. There we go. We've got our sine wave. 1 kilohertz. Seems to be bouncing a little bit there, not super stable. Not too bad overall. And you even have the function to save and pull back waveforms. So if you go save, go back to menu, hit waveform, and there's your waveform. You can view it on the screen. It's a functional little device, I have to say. It's quite nice. It's also quite nice that I don't have to pull out my function gen to give it a little test. But if I were to be extra critical on this, I would say these buttons need a tactile feel. They feel just horrific. The power button being super squishy, I don't mind. It has a light in it, if you can see. But really these buttons, I mean, they don't feel good at all. And they feel like, honestly, they feel like you can go like way into the case with them. Oh, looks like I have to leave the waveform menu. Erase? No. How do I leave? Back to menu? Erase? No. Erase all? No. Not very intuitive on how to get back. Oh, there we go. Back. Back. So far I've done all this without reading the manual, by the way, so it's intuitive enough that you're able to pick it up. So it's not too bad. Let's see about the tilting bail. It's not bad, but with these squish-tastic buttons, you can't press anything without it running away from you. So yeah, I'm liking this thing so far. But in order to give it a full review, I'll have to take some time and really live with it. So the plan is that this and all of its accessories are going to go live in my toolbox, my automotive toolbox. And I'm going to use this in the field on cars. So we will see if this thing survives the squish-tastic buttons and the saving features and all this stuff and the function gen to send signals back to PCMs. What kind of testing would you like to see on this thing for the full review? Let me know in the comments below, and I will put a link in the description if you want to go purchase one of these yourself. Thanks for watching.